Hello, folks. So welcome to part 3 of exploring Godot engine. So I think the last time I was pretty sleepy when I was doing the project. I mean, when I was doing like this part of the thing, I actually apparently read this as accept instead of aspect, and I read this as mud instead of HUD. Anyways, Godot. So let's go ahead and choose this. And not run. I don't know what run means. I'm just going to go ahead and like this edit. That's what I did a few minutes ago and it worked out. So project settings. And I need to go to 2D. No, wait one moment. So scroll to the bottom, stretch. Okay, wait. Project settings. Window. Okay. Window. More 2D. Awesome. What is this? Properties. No, I need 2D. And then keep aspect, right? And this ensures that the game scales consistently on different size screens. So basically, I think we're looking at building a game for different size screens. But we did give a width and height. I'm just wondering, like, maybe it'll just scale accordingly. Maybe, yeah. The width is apparently like lesser, and that is a good height, and that's because of portrait mode. Yeah, it's like this and not like this. Cool. So now in this project, we'll make 3 independent scenes. Yep, I read that. I'm not sure what HUD means. I'm gonna go check it out. One moment. DuckDuckGo HUD full form in games. So in video gaming, HUD or status bar, as I mentioned, is the method by which information is visually replayed to the player as part of a game's user interface. Okay. Okay. So it takes the name from heads up displays. Okay. So HUD is basically heads up display. Right. It's over here. Awesome. Cool. So now, yep, status bar, representing. Cool. So HUD is basically heads up display. And then main scene in larger project, it might be useful to create folders to hold the various scenes and their scripts. But for this relatively small game, okay, so in a very large project, probably in bigger games, you'll have different like folders for different scenes, and then there's scripts for like doing some stuff, like programming some stuff. I'm guessing that's what that means. But this is a very small game, so you can see your scenes and scripts in the project root folder identified by. I'm guessing this means resource : // So you can see your projects folders in the file system doc in the lower left corner. Okay. So let me close this. Does it save everything? Yep, it does. Well, so here, yeah, I can see it. Resources, art, fonts, and all that. With the project in place, we are ready to design the player scene in the next lesson. Awesome. Creating the player scene. So with the project settings in place, you can start working on the player's control character. Okay, so I'm going to control a character. The player is going to control a character, and like we're going to create that scene. We'll define the player object. Okay. One of the benefits of creating a separate player scene is that we can test it separately. Interesting. So they have testing stuff over here. So even before we have created other parts of the game, so you can test it like separately and like as its own unit, as a standalone thing. So to begin, we need to choose separate player scene. Okay. So to begin, we need to choose a root node for the player object. Okay. As a general rule, a scene's root node should reflect the object's desired functionality. Okay. Root node for the, okay. Wait, so they said we need to choose a root node for the player object. Okay, so the object. And as a general rule, a scene's root node. Okay, now they're talking about scene's root node should reflect the object's desired functionality, what the object is. Okay, click the other node button and add a area 2D node to the scene. Okay, what is area 2D? I'm not sure. We'll check it out. So, click the other node. Okay, so in scene we have scene, other node, area 2D. Is it? I can type area 2D. Yep. So collision object, area 2D. Yep. 2D area for detection in physics and audio inference. Okay, cool, done. Display a warning icon next to the node in the scene tree. Yep, it does. So what does it say? A node configuration warning. This node has no shape, so it can't collide or interact with other objects. Okay, so there's no shape, right? I mean, it's an object, and area 2D is supposed to be like a, I don't know. I mean, when I read about it, like it said detection in physics and audio inference. So if there's going to be some physics, it needs to have a shape, weight, size, and all that, right? So weight and all that. So I mean, some mass and all that. So it can't collide or interact with other objects. Okay, so consider adding a collision shape 2D or collision polygon 2D as a child to define its shape. Okay, awesome. So we'll check this out. We'll come back to this. So it has many properties. Interesting. So monitoring, gravity, interesting, and audio and whatnot. And like, yep. Cool. So I'll come back here. Godot will display one icon next to the node in the same tree. Okay, you can ignore it for now. We'll address it later. Okay, awesome. I didn't even have to look at it. Anyway, with area today, we can detect objects that overlap or run into the player. Okay. Change the node's name to player by double clicking on it. Now we have set the scene's root node. Now that we have set it, we can add additional nodes to give it more functionality. Okay. Now I can do enter and type player. Awesome. So, and so we add any children. So we're gonna add additional nodes to give it more functionality. Before we add any children to the player node, we want to make sure that we don't accidentally, I mean, we don't accidentally move or resize them by clicking on them. Okay, so select the node and click on the icon to the right of the log. Okay. Its tool to says make sure this are not selectable. Okay, cool. Choose this. Okay. Group selected nodes, command G, make sure the object's children are not selectable. Okay, done. So yeah, I mean, looks like to ensure we don't have any human errors, right? So just I think select the node and click the icon to the right of the log. Yep, cool. So we shouldn't accidentally move or resize the children nodes, right? Cool. So now save the scene, click scene. Okay, so we have to save it, right? One moment. So this one says star over here. Let me do command S. Okay, save. Okay, this one says save scene as. Can I do save scene? Okay. Okay, click scene. Oh no, not save as. Save, right? Just save scene, not save scene as. Interesting. So on Mac OS, okay. We'll be following the Godot naming conventions. Okay. Classes. Okay, no. Okay, classes or nodes use Pascal case. Okay, variables and functions use snake case like Python. Okay, and constant all caps. Yeah, okay, cool. So what I don't get is this one says scene save. There's no. Okay, let me do this. It says player. Okay, I can just give it just like this. All recognized. Okay, I'm just gonna go ahead and save it. Now, can I do save scene? Yep, it's saving. Awesome. So it's TSCN. I'm not sure what that is. Something to check out. Cool. So click the player node and add an animated sprite. Okay, node as a child. Okay. So you can add this here. Add child node. Okay. We'll handle. So you can do. We'll handle the appearance and animations for our there. Awesome. So animated, right? Animated sprite. So appearance, like how it looks, and then the animation can clearly it says animated, and then sprite is the appearance part, I believe. So notice that there is a warning symbol next to the node, and animated requires a sprite frame resource. Okay. Animated sprite. Okay, cool, done. It's weird that I don't see anything over here. If I go back, yeah, I don't see much. Oops, can't really select stuff, so I'm just gonna leave it at that for now. So there's a warning change, yes, which is node configure sprite frame resource must be created or set. Okay. Um, must be created or set in the frames property in order for the to display frames. Yeah. So basically, it's asking for what do I even show as part of the sprite frame, like animated sprite, what is the animation or like the appearance and whatnot, which is a list of the animations it can display. Create one, find the frames property in the inspector and select inspector. What is that? Okay, here. Oh, this is the inspector. Okay, cool. Node inspector and like frames property, and then click empty new sprite frame. Click again to open the sprite frame. Okay. Okay. So wait. Yeah, now it opens up. Okay, cool. So you have to click again on this to like find out. So if you click here and then you click this, you get this, I think. Sprite frames, you see output, debugger and whatnot. So here you click, you go to inspector, you double click this, you come here, sprite frames, right? Cool. So you can see this panel here. So on the left is a list of animations. Okay. Click the default one and rename it to walk. Okay. Enter, I mean, just walk. And then click the new animation button to create a second animation named up. Okay. Where's the new animation button? Insert empty. After new animation. And then what is it called? Up. Okay, I think, oops, where am I typing stuff? Up. So find the player images in the file system tab. They are in the art folder. Use unzipped. Drag the two images for the each animation named player gray up and then player gray walk. Okay, cool. So art. So into the animation tree side of the panel. Okay, cool. So I can up one, two. Oh, it's like all of these basically. Can I do shift? Yeah, I can move it here. Awesome. So up and this is walk. This is walking on the side, I guess. So this is going up and this is walking on the side. The player images are a bit too large for the game window, so we need to scale them down. Click on the animated sprite node and set the scale property to 0.5, 0.5. You can find it in the instruction under the node 2D heading. Okay. Let's go here. Animated sprite, node 2D, and transform. Yep. So scale. So you basically do this. I think we learned this transformation in like math. So 0.5, 0.5. You do some scaling stuff. Cool. Finally, add a collision shape 2D as a child of layer. Okay. So do I even see this? Can I even see this? I'm not okay. It's a 2D game, right? I forgot. Can I? I can see it. I can see it. Nice. Previously, it was a 3D game. It was I was able to move around and all that. If I change this thing, let me see if I can. Sorry. Let me see if I can actually change this to 1. Yeah, it's big basically. Basically, this is too big. And that's why they wanted to make it small. So you can see here that it's 0.5 and 0.5. Cool. Collision shape. One moment. Collision shape 2D as a child of the player. Okay. So child node. So collision. Oops. One moment. Collision shape 2D. Awesome, done. And then for this character, okay, this will determine the player's hitbox, okay, or the bounds of its collision area. So basically, interesting. Basically, it's boundaries of its collision area. So basically, like if it touches here, then yeah, it's collided, so dead, or like it touches another object, right? So For this character, a capsule shape 2D node gives the best fit. So next to shape in the inspector, click empty capsule shape 2D. Okay. So collision, collision shape, new capsule shape 2D. Okay, someone's at the door. I'll be right back. Okay, I'm back. So capsule shape. Using the two size handles, resize the shape to cover the sprite. Okay. So let me actually zoom in a bit. And then, oh, yeah. Cool. Can I move this down? No, I can't. Cool. So, yeah, I mean, it's kind of close. I think, let me click on this. It's kind of pretty close. So, I think it's a good, oops, I can't move up and down now. Oops. Right, I can't use arrows. Right. Anyway, so can use these though, but yeah, I can't use arrows for some reason. Okay. So resize the shape to cover the sprite. Okay, when you're finished, your player scene should look like this. Okay. Animated sprite, collision shape 2D. Okay. Okay, no errors, no warnings now. If I click this, it becomes invisible. Okay, cool. Got it. So anything under it will also become invisible, of course. Animated sprite, collision, and all that. Okay. So make sure to save the scene again after these changes. Okay. I'll do Command S. Oh, Command S, and you should see the star gone. In the next part, we'll add a script to the player node to move and animate it. Then we'll set up the collision direction to know when the player got hit by something. Okay, cool. So now we are in coding the player. Awesome. So in this lesson, we'll add player movement, animation, and set it up to detect collisions. Okay, awesome. So player movement, I think it's about the up and walk. So and then animation to show that, and then set it up to detect collisions. Okay. So to do so, we need to add some functionality that we can't get from a built-in node. Okay. So we'll add a script. So I'm wondering if you can actually get community build scripts, right? To get such stuff like such functionality. But yeah, if it's custom, like say it's a new game, new idea, I have never like no one has ever come up with such an idea, then like yeah, you'll have to go ahead and like code it. So click the player node and click the attach script button. Okay. There. Attach a new or existing script to the selected node. Okay, got it. So here in the script settings window, you can leave the default settings alone. Just click create. Okay, what is the default settings? GD script, native script, visual script, inherit area 2D, class name, template, built-in script on path. Okay, so it's player.gd. Cool, so create. Sorry, excuse me. So if you're creating a C# script, select the language from the language dropdown before hitting create. Okay. One moment. Okay, so let's see how that happens. Like, I mean, can you say, oops, what did I say? Player.gd, load, okay. What does this say? Detach the script from the selected node. Oops, sorry. Sorry about that. So interesting. So detach, I'll attach, but here you say language. I mean, we are not having other languages, but I guess if you set it up, it will be there. So I've loaded it up. You should not detach it. Sorry about that. If you, first you're encoding please read the scripting languages for continuing. Yep, I haven't done GScript before. Godot engine like stuff. So, but apparently it's like a variation of Python. Let's see. It's an object-oriented and imperative built for Godot. It's made by and for game developers to save you time coding. Blazing fast compilation and load times. Okay, compilation. Okay. It's not an interpreted thing, but it's called script. Interesting. So edited integration with code completion for node signals and more information. Okay. No garbage collection, as this feature eventually gets in the way when creating games. The engine counts references and manages the memory for you. In most cases, very far. And the memory if you need to. Nice. Okay. Gradual typing variables have dynamic types by default, but you also can use type hints, strong typesets. Okay. Looks like Python has a structured code blocks using indentation, but it doesn't work the same way in practice. Okay. Okay. It looks like that. That's all. It's inspired by multiple languages, including Squirrel, Lua, and Python. Years ago, Godot used Python, then Lua. Both language integration took a lot of work and had to, for example, threading support is a big challenge with Python. Doesn't take us more work and we can tailor it to game developers' needs. We're now working on performance optimization features that would have been difficult to offer with third-party languages. Right. So looks like a programming language may not be best suitable for gaming. I don't know. I mean, people are using C Sharp and all, for example, C plus C Sharp. Maybe they wanted to try out a simple language and like simple is hard to get. So start by declaring the member variables in this object we'll need. Okay, extends area today. What about these? How does this look? Okay, C++. Wow. No. This looks complex. Looks simpler. I love this. I'm not surprised that people like JavaScript. Anyways, so can I make this bigger? Yep, I can. I don't want to squint my. So extends area 2D, declare member variables here, examples variable A, B. Oh, hey, cool. So oops, oh, extends area 2D is already there. Oh, it gave an error actually. What's the error? It says extends can only be present once per script. Awesome, done. The speed is 400. How fast the player will move? Okay, maybe I should make it a bit smaller. So yep. So variables, screen size of the game window. Okay. Using export keyword on the first variable speed allows us to set its value in the inspector. Okay. Oh, okay. So I can set its value in the inspector. So wait, layer. Script variables. Interesting. I can reduce this, increase this. Okay, so initial value is 400, I'm guessing, and then you can change it. So initial speed, default speed, or like initial speed, and then you keep changing it using the script so that you export it and whatnot. But why would they provide it here? I'm wondering. Anyways, this can be handy for values that you want to be able to adjust just like a node's built-in properties. Okay. So the default value is here. I don't know. Something to go. Click on the player node and you'll see the property now appears in the script variable section of the inspector. Remember, if you change the value here, it will override the value written in the script. Okay. So this is the main value. Okay. If you are using C#, you need to rebuild the project assemblies whenever you want to see new expert variables. I'm not using C#, so I'm just gonna ignore that. The ready function is called when a node enters the scene tree. Okay. Which is a good time to find the size of the game window. Okay, because we are supporting different screen sizes, and also say if it's a desktop, you can resize the window and all. Like if you're allowing that, then so screen size, get viewport rectangle, rectangle size. Okay, let's do that. Replace with function body. Called every frame. Called when the node enters the scene tree for the first time. Okay. Called every frame. Delta is the elapsed time since the previous F. Okay. So process is something that we have to do. Good. And now we can use the process function to define what the player will do. Okay, so it's like a frame, right? Like it's like a movie. You have every frame or every image to show what's going on. So in this case, delta is the elapsed time since the previous frame, I guess. Previous frame, yep. It's yep. Cool. So it's called every frame. So we'll use it to update elements of our game, which we expect will change often for the player. So I'm wondering what's the frames per second. I always hear gamers saying, hey, 30 FPS frames per second, 60 FPS frames per second and all that. So the how much what do you say? uh, How much detail is there in each animation? Like if it's 60 frames per second, I'm guessing there's more detail because there's 60 frames, so you have more detail, right? But if it's only 30 frames, you have lesser detail. Like and in the same 1 second, you show only 30 frames, so it's like you have more detail and probably I don't know. Sounds like more detail. That's all. I have to think more about this to understand it, but something to check out about FPS. Um, for the player, we need to do the following: check for input. Okay, move in the given direction. Okay, so check for the input, like what are your, let's say I'm using keyboard, so arrows, whatever. Move in the given direction. Play the appropriate animation. Yeah, makes sense. First, we need to check for input. Is the player pressing a key? For this game, we have 4 directions. Inputs to check. Input actions are defined in the project settings under input map. Okay. Here you can define custom events and assign different keys. Awesome. So let's first of all save this, Command S. And then project settings, we have input map. Okay. So here you can define custom events and assign different keys, mouse events, or other inputs to them. And like, okay. For this game, we'll map the arrow keys to the 4 directions. Okay. Mm, one moment. So what do you mean a custom events? I'm not sure. Assign different keys, yeah, I can understand that. And then mouse, yeah, I can understand that. Or other inputs. I mean, I'm guessing you have like say gaming console, any consoles. Say you have a joystick or whatever. But I'm not sure what custom events mean. Okay, so for this game, we'll map the arrow keys. Okay. Click on the project settings, input map, type move right. Okay. So move right. Okay, that's weird. So can I do that? Move right in the top one and click add button to add move right action. Okay. Oh, so these are like UI and stuff. You're basically defining an action, I guess, like our own custom action. I can even write ABCD, I guess. But let's add move right. Okay, so we need to assign a key to this action. Click the plus icon and on the right, and click the key option in the drop menu. Okay, so it's like a keyboard key. They'll ask you to type in the desired key, press the right arrow on the keyboard and click OK. Awesome. Interesting. I like this. So right key, awesome. So it says right. Okay, done. Um, repeat these steps to add 3 more and move left, move up, move down. Okay, cool. Let's do that. Move left, enter, move up, move down, cool, move left, key, left, oops, left, okay. I pressed enter and then it took up enter anyway. So move up, key up. It would be funny if I mess up here and create a bug wherein you say up, but then you put down and then down and up and whatever. Or like put everything as up and then people are like, hey, how do I go in other directions? Anyways, so move down. So yeah, right. So it shows these right, left, up, down. Cool. So I should save it. Can I mean, can I close this and save? And the input map tab should look like this: right, left, up, down. Yep. Right, left, up, down. Yep. Click the close button to close the project settings. Okay. Okay, this I can click this. Okay. And save it. Okay, awesome. Can I also use the close that symbol? I don't know. So you only mapped one key to each input action. Yep, but you can also map multiple. Okay, so this is like you're providing your joystick or say WASD and whatnot. So you can provide the same like multiple things. And it's interesting that how I'm wondering how people customize that. As in some games you can say go to settings and say, hey, for this I want this key to be provided. So you can even do that. So I'm wondering how people do that, but that's an interesting thing. Anyways, like you can say instead of arrow keys, I want something else to go left, right, up, down. So it's more like at runtime when the player game runs the game and like you get it. Anyways, but you can have multiple keys, joystick buttons, or mouse buttons. Okay, cool. You can detect whether key is pressed using input dot is action pressed, which returns true if it's pressed or false. Okay, that's pretty straightforward. And so you get the actions name. Interesting. So whenever you like input and then you get the action, is action pressed? What if they are pressing multiple keys, let's say up and left? Would you get, oh, okay. Maybe I think if you would get both, like you're saying if over here. So yeah, you would get both, I guess. So if multiple keys are pressed, you will have multiple trues and stuff like that, I guess. So yeah. So let's copy this and then put it here. Uh-huh. So velocity, let me save this up. Yep, saved. Okay, so if I make changes here, it doesn't show up. It shows up here, not here though. So this is a script level thing. So I save it, saved. The star is gone. So variable velocity vector to 0. So what is this? So vector 0, 0 comma 0, 0 vector with all components set to 0. Okay, cool. So close. I can do command click and this goes showing stuff. Interesting. So player's movement vector. So it's a 2D vector, so it should just be x and y. So yeah, that's why vector 2. It's a 2D math, yeah. Because you can have 3D vectors where you have x, y, z. Cool. So now input is action press. So move right. So it's like a xy axis. So x plus 1, you go to the right, positive x-axis. Move left, negative x-axis. Move down, positive y-axis. Okay. And then move up, negative y-axis. Okay. So you just do -1. And if the velocity dot length is greater than 0, interesting. What does length mean? So returns the length of this vector. I've read that length is calculated by some formula, like I think C X Y something. Okay, something to check out. What is this? I can see some arrow marks here. Okay, indentations. Okay, these are just indentations. Okay, so if velocity dot length is greater than 0, velocity is equal to velocity dot normalized into speed. Okay, where is speed? Where is this? Sorry, it's here. Sorry, it's like a global thing over here. So velocity, speed, okay, animated sprite dot play, and if it's velocity length is 0, then yep. Awesome. So interesting. We start by setting velocity to 0, 0, which is this 0, 0. Let's go here, which is 0, 0, 1, 1, infinity, infinity, and all that, right? So we do 0, 0. And then by default, the player should not be moving. Then we check each input and add or subtract from the velocity to obtain a total direction. So if it's say right, for example, if we hold right and down at the same time, the resulting velocity vector will be 1, 1. In this case, since we are adding a horizontal and vertical movement, so we do support multi-key press. So the player would move faster diagonally than if it just moved horizontally. Okay. It's because I believe speed, no, velocity, one moment, 2D velocity, one moment, no formula, motion in 2 dimension, so projectile, blah, blah, blah. Okay, this is too complicated. One moment, let's go here, formula for velocity. Let's see if we can actually find out from here. Oops, sorry. Just want to get rid of it. Finding average velocity. Okay, this is too much. Wait. Okay, so root of x square plus y square, I believe that's what it is. Seems like it. 2 dimensions. Yep. Think that's the velocity. Seems like it. So yeah, that's why it's like 1, 1, then it will be a bigger value. Okay. So okay, so this, how will this go back to 0 though? You press left, yeah, it will slow down. You keep pressing right, it will keep speeding up, right? Yeah. Would faster diagonally than it, okay, so we can turn that if we normalize the velocity, which means we set its length to 1. Okay. What is this? Normalized? What is normalized? No idea. Normalized into speed, okay, is greater than 0. Okay. Velocity equal to this. Interesting. By the way, how is velocity even like related to the players? Like how is this connected to the player? Like there is a velocity variable, yes. Player's is movement vector. How do you even connect this to the player? Like where is this even mentioned that this is it belong? Okay, so that's because of this. And anything named velocity is this the velocity movement vector? I don't know. How do you say that this is particularly velocity? Like because you just assign a value to this. You didn't tell anywhere like this. I could just name it V or whatever. Not sure. Let's see. The resulting answer will be okay. So you can try that. The normalize, okay, so then multiply by the desired speed. This means no more fast diagonal movement. They've never used vector math before or need a refresher. Yep, I need a refresher. Or like I've never, I mean, I've used, but I don't know much in this specific situation, especially. You can see an explanation of the vectorization, Godot, and vector math. Okay, it's good to know it, but won't be necessary for the rest of this tutorial. Awesome. So, vector math. Okay, there's quite some stuff. I'm going to go ahead and read this a bit later. Scalar multiplication. Interesting. Practical applications. I'll come back here. Or should I read this? It's not much pointing to it. Okay, let's quickly check this out. This tutorial is a short and practical introduction to linear algebra as it applies to game development. Study of vectors and their users. Vectors have many applications in both 2D and okay. This is extensively developing a good and is essential to become a strong game developer. Okay. Not a formal textbook on we'll only be looking at how it is applied to game development and broad look and see. Nice. Cool. So coordinate systems in 2D space coordinates are defined using like x-axis and y-axis, okay, horizontal and vertical, a particular position. So yeah. Interestingly, I remember like a lot of graphs you have the right x is like the positive, this y as the negative, and the above y as positive. But in computers, it's always below y is like positive and above. Computer graphics is when I seen are that positive. Yeah, see, positive y axis points downwards. So in computer graphics alone, like all learned in math plus instead of upwards. However, this is common in most computer graphics applications. Yeah, so it's downwards. Any position in 2D plane can be identified by a pair of numbers. Yep. In this way, however, you can also think of the position 4,3 as an offset from 0,0 or origin. Draw an arrow pointing from the origin to the point. Okay. This is a vector. Okay. A vector represents a lot of useful information as well as telling us that the point is 4,3. Okay, so we can also think of it as an angle theta, okay, and a length of magnitude m. In this case, the arrow is a position vector, okay. It denotes the position denotes the position space related to the origin, okay. Point to consider about vectors is that they only represent a relative direction and magnitude, okay. So there's no concept of a vector's position. The following two vectors are identical. Okay. Okay, so it just represents a direction. Represent a point towards 4 units to the right and 3 units to the bottom, like below some starting point. Does not matter where on the plane you draw the vector, it always represents a relative direction and magnitude. You can use either method, x and y coordinates or angle and magnitude to refer to a vector. But for convenience, programmers typically use the coordinate notation. Okay, for example, in Godot, the origin is at the top left corner of the screen. So to place a node named to the right, and you just say 400, 300, I guess. Yeah, vector 2. Awesome. So Godot supports both vector 2 and vector 3 for 2D and 3. Okay. The same mathematical rules discussed in this area apply to both types. Okay, member access. You can do dot x dot y, adding vectors, just add them and you get stuff. Okay. You can also see this visually by adding the second vector at the end of the first. Okay. So first vector, second vector, one, I mean, this is 3, comma 1, and then 2, comma 5, 1, 2, 3, 4, 5, yeah, 2, comma 5. No, 3 plus 2, 5, and then 6. So you just, you know, point here. Okay, so this is 5, comma 6. Note that adding a plus b gives the same result as b plus a. Yep, it does. I mean, these two you add, however, you will get the same. I'm wondering how. Oh, okay, okay, okay. So, this is a, and then you have a parallel vector over here, and then you draw it here, and you get this point over here, right? And you draw a parallel vector here, you get the point over here. So this plus this is this, and this plus this is also the same. Scalar multiplication vectors represent both direction and magnitude. Okay, direction is this. Magnitude, a value representing only magnitude is called a scalar. Okay, it can be multiplied by a scalar. Okay, so into or divided also, like multiplied by a fraction. So into 2, so 4, 10, and then 1, comma 2. Okay, awesome. So you just increase its magnitude. Okay, so but multiplying a vector by a scalar does not change its direction, same direction, but then magnitude, the length changes. That's how you scale a vector. Scalar scales, scale vector. To common uses for vector addition and subtraction movement, vector can represent any quantity with a magnitude and direction. Okay, magnitude, the length, and all. Typical examples are position, velocity, acceleration, and force. In this image, spaceship at step 1 has a position vector 1, comma 3. Yep, 1, comma 3, and a velocity vector of 2, comma 1. Okay, so 1, comma 3, and then that. So this is a position. So this is a position. Velocity in this direction it's going, right? So 2, comma 1, right? So this direction 2, and then bottom 1. So the speed would be basically. I mean, it has to go this direction. Speed is what, or the velocity, I mean, would be basically the length of this 2, comma 1 thing. I don't know. The velocity vector represents how far the ship moves each step. Okay. You can find the position for step 2 by adding the velocity. You just add the velocity. Okay. To the current. So this is the velocity vector. So you just add it up like 1 plus 2, 3, 3 plus 1, 4. So you just do, 3, I mean, 3, comma 4, which is this. 1, 2, 3, yep. 1, 2, 3, 4, yep. 3, comma 4. Measures the change in position per unit of time. So the new position is found by adding velocity to the previous position. Okay. Pointing towards the target. Okay. So you point towards the target. So in this scenario, we have a tank that wishes to point its turret at a robot. Its turret at a robot. Okay. So this is the turret. Subtracting the tank's position, which is this, and then from the robot's position, this. I mean, this minus this, I don't know. Gives the vector pointing from the tank to the robot. Interesting. Why is that? So this minus this will give this. So tank position minus robot position equal to robot minus tank this direction. Okay. Now, just wondering, wait. I think there must be, okay, I'm not able to think about the exact math over here. So if it's, what if it's like this minus, okay, wait. So tan, so 1, 2, 3, 4, and 1 to 3, so 4, comma 3, and this one is like 1, 2, 3, 4, 5, okay. 1, 2, 3, sorry, 1 to 3, 3, comma 5, and this is 4, comma 3, 3, comma 5, 4, comma 3, okay. Now 4, comma 3 minus 3, comma 5 is like 1. Sorry, I have to write it down. One moment. I could write it down here. So this is 1, 3, 4, 4 comma 3, and then sorry 4 comma 2. That was 4 comma 2. 4 comma 2, and then 1, 2, 3, 4, 5, 5 comma, oh no, that's the y. 5, 1, 2, 3, 3 comma 5. So now if I subtract these two, I would get interesting. Uh, hmm. I have to do subtracting the tank's position from robot's position. Okay. So from robots, so first you subtract this from robot's position to minus tank. This minus this will give you this. So 3, 4, I mean this minus this. So it's 3 minus 4 minus 1. And then 5 minus 2, 3. So it's minus 1 comma 3. Minus 1 is basically side, like basically, I mean, 3 is positive, so it's downwards. But minus 1 is like negative x, so it's left and not right. So it's this way. So you get this direction. To find a vector pointing from A to B, okay. A, B, A, B. It's B minus A, huh? Okay. A to B, you need like A to B some direction, you just do B minus A, right? So now unit vectors, magnitude 1 is called a unit vector. They are also sometimes referred to as direction vectors or normals. Okay. And it is helpful when you need to keep track of a direction. Oh yeah. Normalization. Ah, this is what we are looking at. Normalize. Okay, so magnitude 1 is called a unit vector, direction vector. So because since its magnitude is this one, you focus on the direction because it does not have any magnitude, and like it's not going to help you with like velocity. I mean, could be like velocity is one or whatever, but you need to keep track of a direction. Normalizing a vector means reducing its length to 1 while preserving its direction. So this is done by dividing each of its components by its magnitude. Okay, so you basically are doing that here. So and then you're multiplying by c. Okay, so this is done by dividing each of its components by its magnitude. Because this is such a common operation, provide a method for normalizing. Okay, cool. So because normalization involves dividing by the vector's length, you cannot normalize vector of length 0. Attempting to do so will result in an error. Awesome. So only when the length is greater than 0. If it's 0, it will result in an error because the magnitude will be 0 and you divide by 0, it's a problem. Reflection, a common use of unit vectors is to indicate normals. Normal vectors are unit vectors aligned perpendicularly to a surface, defining its direction. Okay. Reflect. So this is the motions, but you have to reflect. This is the normal, and you reflect it perpendicular to a surface, defining its direction. They are commonly used for lighting, collisions, and other operations involving surfaces. For example, imagine we have a ball moving that we want to bounce off a wall or other object remaining motion, but you have an obstacle here. The surface normal has a value of 0, -1 because this is a horizontal surface. When the ball collides, we take its remaining position, the amount left over when it hits the surface, and reflected using the normal. Oh yeah, so what does that mean? In classes of bounds method to handle this, here is yeah, kinematic body 2D, move and collide. Interesting. Dot product is one of the most important concepts in vector, but is often misunderstood. Dot product is an operation of two vectors that returns a scalar vector which contains both magnitude and scalar value only has magnitude. Okay. So okay, I didn't get that. Two forms. Okay. In most cases, it is easiest to use the built-in method. Note that the order of the two vectors does not matter. Okay, so A dot B, B dot A. Cool. So this gives a scalar which is just a magnitude. The dot product is most usually used with unit vectors, making the first formula reduced to just cos theta. Okay. A dot B. A dot B is less than 0. Okay, I didn't get that part. And using unit vectors, the result will always be -1 and 1. Okay. Okay, when using unit vectors, the magnitude will be 1 here and -1. Okay, 180, 180. Okay, then it will be -1. Okay, 0, 0. Okay, cool. So same direction, 1 into 1. I think that's fine. Anyways, I'm gonna have to check that out again. Facing. Okay, that's a lot of stuff. Cross product. I've learned some of this stuff, but it's interesting to see how it's properly applied in game development. I'll come back here now. So we also check whether the player is moving in. So we call dot. So we can call play or stop on the animated sprite. So here, if the velocity is greater than 0, so play, or else 0, stop. Right. Dollar is shorthand for get node. So in the above code above, dollar animated sprite dot play is the same as get node animated sprite dot play. Okay, cool. So in GDScript, dollar returns the node at the relative path from the current node, or returns null if the node is not found. Since Aaron is a child of the current node, you can use animated. Okay, cool. I mean, we know that player has animated sprite, or else this is going to be a problem. Cool. So now let me close this off. And now that we have a movement direction, we can update the player's position. Okay, so this is only the velocity and stuff like that, right? Now we have to move the position so that it moves. Okay? So that's how you connect the velocity to this player. So you are now saying, like now that we have direction, okay, we can also use clamp to prevent it from leaving the screen. Okay, clamping a value means restricting it to a given range. Okay, add the following to the bottom of the process function. Make sure it's not indented under the cells. Okay. So, okay, so position. So here, indented. Okay, save it. Cool. So you said velocity into delta. So delta is the previous time. So velocity is displacement by time, and then time to remove. So you get displacement. For the speed bar, and then like now how much? No, how much displaced? How much is it displaced? Not the speed. This speed is distance by time, velocity is displacement. So how much displaced? And then this is basically what position. And you say position dot x is equal. So do you even define that position is actually a 2D? I don't know. Velocity 2D vector, right? So you do multiplication, which is like, I don't know, dot product. What does it mean to do cross? I think it's cross product, is it? I don't know. Facing cross product. Yeah, it's a cross. I mean, this is 3D vector. Um, cool. So looks like this is kind of like a cross product. The delta is basically the time, and like so now here, something so good. And then clamp the position. So x should be between this minimum value and this maximum value. A is 20. Okay. What does A mean? A is 1. Oh, A equal to, okay, 20. So I'm guessing you provide the position and then you say 0 to, it should be within the 0 to this, right? So you provide 1000, it should be within 1 to 20. So now it will clamp it to 20. Minus 10 to 1, 20, it will clamp it to 1. 15 to 1, so it's reducing, it will clamp it to 15. Yep. Cool. So now, once that is done, one moment. The delta parameter in the process refers to the frame length, the amount of time that the previous frame took to complete. Using this value ensures that your movement will remain consistent even if the frame rate changes to 30 frames per second, 60 frames per second. Click play scene and Command R on macOS F6. Okay, let's first of all ensure that it's all saved. Play scene, Command F6. Okay. Where is play scene? I don't see play scene. Interesting. Let's see. Script. Can I do sub resources? Okay. Can I do Command R? Yep. Cool. So now it's doing stuff. Can I press? I can press. I can press right, left, down. Interesting. And I can go up. Can go left, right. Some weird reason it would. I don't know. Interesting. And it's clamping stuff. So yeah, it's not going away, right? Interesting. I remember actually creating a game long, long ago where I had to actually take care of all of this. If I resize this, I think it will take care of it. I don't know. No, this is like a fixed size thing. Nice. Oh, okay. So like, so this height will accordingly change. Cool. So now I can close this. This is in debug mode, right? Dodge the creeps, debug mode. Cool. So I just had to do, Command R or F6. I'm guessing F6 should do it. No, Command R. Command R does it. F6 doesn't. Okay. So now close that. And if you get a error in the debugger attempt to call function and base null instance on it, this likely means you spelled the name of the animated sprite node wrong. Node names are case sensitive and must match the name you see in the scene tree. Okay, cool. So if I do something wrong over here, it should give an error, right? Same command R. Yeah, see, attempted to call function play in base null instance on a null. Yep. Cool. So it's always good to see errors. So let's also do some stuff here, right? Command R, and it stopped here itself because here the only when the velocity is greater than 0, this will come up. Here initially itself it came up and it like it said stop, but then already failed here. So animated sprite. Let's do this. Yep. Cool. So now if I do save and then command R, should just work. Awesome. So now I'm just gonna go ahead and close this. And cool. So now that the player can move, we need to change which animation the animated sprite is playing based on its direction, right? Because currently, if you see, it's weird. Like when it goes down, it's looking up and like it's looking right and up, right, and it's going down or up. And it's going right, it's looking up and right. When it's going left, it's looking up and right again, right? So interesting. So this is in what? This is okay. So which one is this? This is a blue one. This is a gray one. I think this is the one. And yeah, the blue one is the game. Okay, so now okay. We have the walk animation, which shows the player walking. So to the right. Okay. You can actually say the like so here you're saying flip hitch. Flip hitch velocity. Okay. So we have the walk animation, which shows the player walking to the right. Okay, one moment. Let's see if we have those animations. Right. Animated sprite. Yeah. So this one, this one, this one, this one. Okay. So I should have actually I should have actually added properly the stuff over here. I put for everything in up. So this is up. This is for sidewalk, I believe. Let me actually try to get these out. Delete, 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 delete. This is for up. This is for up. And then this is for walk. This is for walk. Cool. Let's save this. Let's do command R and like now let's go right. Right. So now it's like just looking it up. Yeah, it's not doing it. We can see different like what do you say animations. but yeah, I mean, doesn't show like up and right, like bottom or whatever, right? So here you can see that the animation has to be collision. Animation has to be like going right, up. Ah, that's all. I think that's all. Interesting. So flip V false. Hmm. I think everything is good in this case. Based on the direction, like, okay. Hmm. So one moment, clear, animated sprite. It has to be like this. Ah, and it's going right, it should see right. Going up, it should see up, right? Now what does it do? It's going up, it should see up. It's going right, it's not seeing right. That's the problem. When it's going right, it's not seeing right. But when it's going up and all, like it's always seeing up basically, right? I believe up is like the default thing. If you had walk on the top, I think it might be different. Anyways, so now we say when the velocity dot x is not equal to 0, which is the right side, you walk. Velocity dot y is like not equal to 0, which is like going up and down. So you just say up. And according to them, there's no down, I guess. So according to it, it's just up. So flip V false. See the note below about Boolean assignment. Okay. Flip H. Ah, wait. So if it's not 0, walk. Okay, so it's sideways walking. And flip V vertical, false. Flip horizontal, less than 0, true, false. Okay. So if x is less than 0, it should like basically look at what it is. Okay, Boolean assignments in the code above are a common shorthand for programs. Since you're doing a comparison test Boolean, sending a Boolean value, we can do both at the same time. Okay. So if x is negative, which is like going in the left direction, then it would be true. So flip H true. Here, flip V alone is there, which is true in case the V is like positive, which is downwards. Or else it's false and it's upwards. Okay. Interesting. So if velocity dot x, okay. Interesting. So here, so instead of doing this, they would have just done this. Play the scene again and check that the animations are correct in each of the directions. Okay. So animated sprites. Where do we put this though? Like, okay, so here choosing animations, we have the walk animation which shows the player walking to the right. This animation should be flipped horizontally using the flip H property for left movement. Okay, so this will be flipped accordingly to the left when you're moving left. And you'll also flip it bottom. So this animation should be flipped horizontally using, okay, so horizontally. Okay. You also have an up animation which should be flipped vertically. So horizontally. So horizontally flip. Is it horizontally flip? Horizontally flip. Vertically flip and it'll go down. So horizontally just flip like this. Vertically flip like this. So yeah, I mean you do the horizontal, like, okay, this is the horizontal. So in the horizontal plane you flip, it goes this way. Vertical plane you flip, it goes downward. So it should be flipped vertically with for downward. Let's place this code. Okay. So where do I place this though? Should I just place it here? Oh yeah, it's interesting. Oh yeah, cool. Now we're good. Let me save this. So if the velocity is negative, I mean, sorry, not negative. It could be positive or negative. If it's not 0, the x is not 0, then you walk. And It's on this side, right? So you just walk. You don't have to flip the up and down. You do have to flip the X, right? I mean the I's. So if the I mean for walking, you see that the right is already there. So this is the thing true, right? I mean you don't have to flip if it's like this, right? If it's negative, you have to flip. Positive is like X is this direction and it's going to go. You don't have to flip. It's already like this on the right. You have to flip it to the left in case it's negative. So X less than 0, yeah, like it's true, then you have to flip it, then it'll get flipped like this. And I think you should say when flip V false. I don't know why. I mean, here also we should say flip H false, or maybe this is not needed. I don't know. Here velocity Y, you know, in case like there is some velocity Y, you have your up animation, and if you want to like flip it, you'll flip it only when like, so in up animation we are looking up by default. So if it's positive, if it's negative Y, you have to look down, because sorry, look up. If it's positive Y, you have to look down. So currently it's up, so you flip when you're looking down. Down means positive Y, so positive Y, then flip it so that you're looking down. Let's see if how this runs now. So this, yep, awesome. So you're flipping your eyes, your whole thing is like showing up. Interesting. And you go left, right. Awesome. Interesting. I'm wondering if this is needed though. Can this be removed? Just wondering what will happen if this is removed, right? Go right, go up, down, right, left. I don't know what that helps with. I mean, yeah, up and right, I can go diagonally. Up and right, I can go diagonally. Bottom and right, I can go. Bottom and left, I can go diagonally. Bottom, I mean, left and right, okay. I'm not sure why that thing helps though. Could also put flip H falls, over here. Like, I'm not sure what's the point of this. Like, don't flip H. That's all. Like, when you're doing Y stuff, don't flip H. What if you do that? Go down, go up. So, oh, okay. So if you're doing both up and right, let's say, would you look up or right? Like, interesting. I think that's where the question comes up. So in this case, when you're looking at, say, velocity is positive or negative, would you flip H or not? Really depends. If it's already flipped, I think you wouldn't, because this is like you're already looking at, so let's say looking at left, you look it up, you look at left, right, down, left. So you look at right, and you do both up and right. You look right, okay. You look down, you do up and down. Okay. So you do down, you do this instead. So right. So you would rather just this is fine. This is not fine. Like you go down, you go up, you go down, you go side, let's say. You go down and then you go side. You're moving along X and you say flip V, vertical false. But if you're moving down, you say flip H false, which is this flipping is false. Interesting. So if I remove this off, something to check out. Oops, comments are like this. Okay. Okay. So, interesting. So, however, this is only happening like left up, right down, left down, up. Cool. I'm not sure. Like, I have to go check out. I'm missing out something over here. Something to think about again. Problem sleepy. Anyway, so the Boolean assignments are done. Okay, and check that the correct animations and check that the animations are correct in each of the directions. Okay. A common mistake here is to type the names of the animations wrong. Yeah, okay. So it's like capital W, then it's going to be wrong because there you define a small w. Animation names in Sprite must match what you type in the code. If you name the animation capital W, you must also use a capital W in the code. Okay. When you are sure the movement is working correctly, add this line to ready. So the player will be hidden when the game starts. Okay. Okay. So, and so they will be hidden when the game starts. Okay. So hide. So this is the player's code, right? So you're just hiding them. You click on hide. Canvas if it's currently visible. Hide is equivalent to setting visible false. Cool. Close. Save. Awesome. Think this should be the second line. I'm not sure though, but just gonna leave it at that. And then we want player to detect when it's hit by an enemy. Yeah. But we haven't made any enemies yet. Yeah, of course. So that's okay because you're gonna use Godot signal functionality to make it work. Add the following at the top of the script after extends. Okay. Signal hit. At the top. And let's save it. Okay. This defines a custom signal called hit. Okay. Oh, so this is like an event-based system wherein you have a event or a signal, which is called hit. This will happen when there's a collision. You define the name for this. So called hit that we will have our player emit or send out emit events and like or signals when it collides with an enemy. You'll use area 2D to detect the collision. Select the player node and click the node tab next to the inspector to see the list of signals the player can emit. Okay. So player node and then node tab player from the script area 2D can actually list of signals. So this can give a lot of signals. Body entered, body shape exited, body shape entered. Okay. So notice our system custom hit signal is there as well. Since our enemies are going to be rigid body 2D nodes, we want the body entered signal. This signal will be emitted when a body contacts the player. Click connect and the connect signal window appears. We don't need any to change any of these settings to click connect. So click on it. Okay, so body entered, connect, receiver method. Okay, we don't need to change any of these settings. Okay, on player body entered. Okay, connect. Okay. So click on it. Godot will automatically create a function on player body entered, body replace with function body. Okay, so note the green icon indicating that a signal is connected to this function. Okay. Signal and then target is this. Okay. Function add this code to the function. Okay. So hide player disappears after being hit. Yep. So that you can say game over and all that. And then save this. Emit signal hit. This is giving an error. No, that's good. And then must be deferred as we can't change the physics properties on a physics callback. Okay. Each time an enemy hits the player, the signal is going to be emitted. You need to disable the player's collision so that we don't trigger the hit signal more than once. Okay. Disabling the area's collision shape can cause collision shape 2D. So basically, deferring it can cause an error if it happens in the middle of the engine's collision processing. Set deferred tells Godot to wait to disable the shape until it's safe to do so. Okay. So you can't immediately disable it. Instead, you defer it. So So yeah, I mean it's doing some processing and all that, right? So at that time it can be weird if you disable the you know the collision 2D shape 2D itself. So last piece is to add a function. Okay, creating the enemy main game scene. Okay. So is to add a function we can call to reset the player when starting any game. Okay, cool. So I'm gonna copy this. I think with this I'll probably continue in another video. It's a pretty long video. Hmm. Last is add a function you can call reset the player when starting a new game. Okay. So you can call reset. Okay. So I think this is like a custom thing. I'm not sure. The position is equal to pause position show disable default. Okay. So we can call this to reset the player and then starting a new. So in starting a new game, like let's say you got hit or this is the first time you're playing the player working will work on the enemy in the next lesson. Cool. So I'll see you in the next video for the player and for the enemy. And then we'll be doing the main game scene and then HUD, heads up display, and then finishing up. I'll see you in the next one. Bye-bye.